Hello everyone. I know it's quite late already, so I'll try to be brief. Actually, I think I prepared a lightning talk, not exactly a big talk, so I won't torture you that much, and we can go all for pizza and beers as fast as possible. So, few disclaimers before we start. I have a 9-month-old baby at home, and I haven't been sleeping much. That's why the long face, okay? But I'm actually very excited to deliver this talk. Second disclaimer, not exclaimer. The body of work that I'm going to show you is the result of teamwork, so I'd like to give them some credit as well. I'm not exactly the mastermind behind everything I'm going to share you here. And yeah, that's it. So my talk is about the CQRS architectural pattern in Azure, a cloud-native context. Actually, that's my third disclaimer. It will be more about a story of the evolution of an architecture with a business. Okay. So the agenda for today will be. I think I'm having an issue here. Yeah. So the agenda for today is that I'm going to give you some context. I'm going to introduce you the story of my company, NetworkMe, because I think it's important as well to introduce what's going to come next. Then I'm going to give you some technical concepts warm up, just to explain you some things and warming you up into what I'm going to explain next, which will be our final architecture, what was the end result. Okay? And in the end, I'm going to summarize everything and leave you with a take-home point, which I hope will be valuable for you, and that can be productive for your work as well at your own companies. So, NetworkMe, we are a career platform for young talent. We basically help students find their first job, and we developed this company because we understand there is a problem, the problem of young talent having a hard time making such an important decision, and at the same time we understand that companies, they actually have a hard time as well contacting, communicating with these young talent, and finally hiring them. So in practice, we use educational journeys that approximate companies from students and help companies as well without the whole process of working their employment brand, actually doing recruitment processes, and so on. Currently, we have over 90 companies that work with us. Most of them are in Portugal, although we have some in Spain, and currently we are opening the Brazil market, and we have a few of them there as well. So, as I told you, I'm going to tell a story. I'm going to tell the story how in September 2021, when we launched the first version of our product, how we went from there to now, and how we went from 1 software engineer to 7 software engineers. How we went from supporting 1 country to supporting now 3 countries. How we went from having a single product to now having over 3 products. Actually, we are releasing a 4th one very recently. How we went from 2,000 users to now over 80,000 users, and from 0 clients to 90 clients. Okay? And I want to tell you the story of how all of this evolution of our business actually made us go from an initial architecture, which is extremely simple, but that ultimately it worked really nicely for the moment we were in September 2021, to something slightly bit more complex that supports a lot more features that we needed as well for the stage that we are right now in terms of our business. And to give you some context for why we went through this evolution, actually, I'm going to share some of my concerns and what I went through to make the decisions of the changes we wanted to have. So the first one is that we had a degradation of read performance due to increase in domain complexity. So the idea is that when we started, we were a job portal for students, right? So the domain was quite simple. And then we introduced workshops, we introduced educational content, we introduced simulators, we introduced a lot of many things that over time increase the domain complexity of our product, right? And we had a few strategies that we could use here to address this. For instance, we could have possibly break down queries into multiple queries, but then that made it more complicated on the UI side to make the integration. So we sort of tried many things, and then we went to a different way, which I'll explain very soon. The second thing is that we have a read-intensive application, meaning that the load on read resources is way higher than on write resources, right? Also, we need to support multi-regional availability, since we are now moving to a new market, which is on a completely different region. While we were just in Portugal and Spain, it was fine because we use France Central as our cloud region, so it doesn't really matter that much. But then we went to Brazil, and Brazil is 5,000 miles away, exactly. And therefore, we need to probably support we have to have infrastructure there, so the users that access our application from Portugal, they have the same performance of those that access from Brazil. And also, we need to scale up to more than 2 million users. Just so you have an idea, we are talking with a private educational group in Brazil, and just that specific group has over 2.5 million users, students, which hopefully will convert to users, which is an entirely different reality than Portugal. So Portugal is only 200,000 students that will likely use Network Me. Spain will be closer to 1 million, 1.5 million, but it's still relatively low. When you think about going to Brazil, you are talking about millions and millions of users, more than 10 million for sure. And therefore, we need to have that scalability power to grow up to at least that amount of users. And also, as you might know, as you increase the number of people working on a product, the architecture also needs to accommodate that, right? So we have a talk right now talking about infrastructure as code. When it was just me, Marcelo, working the product, I didn't have to be concerned with the infrastructure as code, right? Because it's just me. I can just go to the cloud, up the resources, and play with it. But with 7 developers, things change a bit, right? You have more people. You need to understand that there is an orchestration of people with software, and that those things need to be concerned as well in the architecture. Wait. I think it's low battery. So now going to the technical warm-up, I'm going to introduce you a few concepts. The first one is the Command Query Responsibility Segregation pattern. And this was actually the key thing that we needed to unlock for making an architecture that supports or fixes all the concerns that we have. Okay? So this is actually very simple. It's harder to implement, but conceptually it's very simple. The idea is that we are going to segregate write operations from read operations, right? And practically the way you can implement this is having different APIs for reading operations, reading different databases for read operations, and vice versa for write operations as well. And to support actually this pattern, we were to move as well for event-driven architecture, mostly to communicate between services, all right? And it will be clear when I show you the final architecture, but just to explain how this works, it's very simple. You have services, web apps, whatever, they produce events, right? And then we have like an event, let's say broker, that is going to dispatch that for different consumers, and then the consumers are going to read the message and do some processes with it, right? Or trigger some processes with it. But yeah, it's quite simple. It's just something that orchestrates communication between services. That's the best way to think about it. And yeah. And then finally, microservices. I think most of you are familiar with it, but since we moved from having one person working in an application to 7, it becomes way easier to have that software broken down into small bits instead of having a big bit, a monolith, which was what we had before. And again, it worked fine at the moment. And yeah, the way it works is that we basically encapsulate, or at least in our case, we encapsulate different domains into different microservices, and we separated them by that. Now, just to talk as well about some services, Azure services that we are using. Azure SQL Databases, it's just an SQL database which is managed by you. Extremely simple to understand as well. Azure App Service Plans is how we basically host our APIs. Okay, it's basically a managed service to host APIs. Azure API Management, we use it as a consistency layer. We can basically aggregate all the different APIs into a consistent API and then apply some security measures and some other things into a layer that basically interfaces between your backend and your front end. We are also using Azure Cosmos DB as our NoSQL/read database. And Azure Service Bus basically as our message broker to handle all the communication between microservices. So the end result is this that you see here. And now I'm going to proceed to explain you more or less what's going on. So on the front-end side, and I wouldn't like to focus so much there, but on the front-end side, we are using Azure Static Web Apps that use CloudFront as a way to cache, to improve caching, but as well to apply some rules engines, okay? The static web apps, they interface with APIM, where we have our consistent API, and then our APIM is going to interface with our backend service, which are basically app services in app service plan. Okay, we probably could do some improvements there. In the future, if we'd like to scale this horizontally, I can probably put app service in each app service plan and then scale vertically from there. But at the moment, we don't see the need. We don't have so much load in write operations, and we don't think that it's necessary to make them move. The backend is interfacing with the SQL database to write operations. Okay. In the middle, we have Mixpanel as our product analytics tool, and we have Application Insights as basically our logging service to log mostly technical logs. Okay. And as our authentication system, we are using Clerk. Okay, Clerk is a very recent authentication system. In the past, we used Azure ADB2C, but we had a really bad experience. It's hard to customize, it's very slow. And recently, we decided to move to Clerk, and it's working really nicely. And now, please pay attention to this part, because this is actually where the CQRS pattern is being implemented. So these APIs that you see there, they are just for writing operations. So the only thing they do is they write queries, they write to the database, and then they trigger a message. Okay, that message is being orchestrated by Azure Messaging Bus, and it's going to a new API, which internally we call it Data Streamer. Okay, that API basically consumes the message and then reads the information from the SQL database as needed, and then reconstruct it to then write it in Azure Comms DB as our main read database, but also Elasticsearch and RecomB. RecomB is a recommendation engine, and we basically use it to deliver item recommendation to users in our web interface. So recommending job opportunities, recommending content, educational content, and so on. And then the client, our web static web app, is going to read directly from these different databases for the different use cases that we have on the UI. Okay? So this is more or less the way we are doing things back in Network Me. It works fine. We are satisfied with it at this moment, and that's important at this moment. But now, just to conclude the presentation and make you a brief summary of what we talked about here. So we talked about how business context impacts technical architecture, right? We talked about architecture patterns like the CQRS pattern, the event-driven architecture pattern, microservices. We mentioned some cloud services, Azure SQL databases, Azure Cosmos DB, Azure App Service Plans, API management, and Service Bus, right? And we put it all together into the current architecture that we are using back in my company, and basically how all of these concepts, they play together, right? So as a take-home point, and to complete my presentation, I would like to share with you like a very important learning I had over the years, which is there is no really like strictly bad or strictly good technical architectures. Back when we started, we had a very simple architecture. It didn't support that many features, but actually it was perfect at the moment we were. Because it was just a developer work on it, we need to be very rapid in the way we developed, and architecture actually slows development processes sometimes. And it was fine, right? And what I brought you here is a story of how an architecture moved from a business that at a stage that it was fine, to an architecture that had to move on and evolve with the business, right? I didn't tell you a story of we went from a bad architecture to a good architecture. I told you a story how we, over time, aligned our technical architecture with what our business needed. And I think that's most important, and sometimes we technical people, we forgot a bit the requirements of the business, and we do things because it's awesome and we are techies, right? But we cannot forget that in the end of the chain, there is a business to which we need to deliver value, and delivering value meaning that we do software, we do technical things that align with what the business needs, right? So with this, I end my presentation. Thank you so much, and now I'm open for questions and answers. Thank you.
Thanks, Marcel. Thanks. Amazing. So, any question for Marcel? Yeah, this time, yeah. Yeah, please feel free.
So hi, thank you for the presentation. Also, congrats on the business, on the project, on the evolution, a clear evolution of the project. Yeah. So my question, there are two questions, but they are easy, I guess. Mostly, I'm a backend, so I get a request and a response. So I didn't understand the concept of event-driven architecture. So if you could just a brief description of what it is, it will be great. Yeah.
Yeah, absolutely. Thank you for the question. So very simply put, an event-driven architecture that means that you use events to interface or to communicate between services, right? In our practical use case and answering to actually putting myself in your role, when you develop backend, you think about query and response, right? You receive a request and you deliver a response. And we still do that. The only difference is that when we receive a query, besides doing all the operations that are necessary, we are also sending a message to another service and saying, hey, something happened here, and because of that, you need to do this other operation, right? And maybe your question is, but why don't I do that in a row, right? I could, but that would hinder performance, writing performance a lot, right? And by doing that, you can actually serve the request way faster, right? And you can do those heavy operations in the side, right? As an example, we have a document, which is the user document, and it's a massive document, okay? It has like 10, 11 lists, right? It needs to read from 40, 50 different tables, right? And if I make a request to update that user document in my database or the user table, or any of the tables that are related to the user, and then I have to reconstruct that document again in an NoSQL database, in this case Azure Cosmos DB, the request would take like 2 seconds, right? Because, not 2 seconds, but a lot, okay, more than it should be to not damage the user experience, right? But by doing that, you are actually leaving that responsibility to sync data between SQL database and the NoSQL database documents in another, at another, on the side, at another place, you see? So that's basically the utility of an event-driven architecture, or that's the way we use it at least. Did I answer your question? Was it clear?
Yeah, I think I got an abstract way. Yeah. So basically, when a request has a lot of complexity, it's if we can bundle that and have a better management of the complexity if it's if it's grouped.
Absolutely, and also because when you think about a microservice, right, you don't want to give it too much responsibility, right? And the responsibility of the microservice is not to reconstruct the data in Azure Cosmos DB, ReckonB, Elasticsearch. It's just to write, is to apply the business logic, right, and to write to a database, right? So all of those operations that they are not concerned with microservice, they can be pushed back to another service. In this case, we call it data streamer, which the responsibility is just that, reconstructing documents from SQL database to the different NoSQL database that we use.
One advantage it should be the error handling, because it will be a nightmare for a microservice to manage. It won't be possible due to the so many steps, complexity of the flow. Yeah. Okay. So the other question was about Clerk. Is it? I didn't quite catch it. Is it an access management tool for the right APIs? Is that it? A dynamic.
Yeah. Do you know Azure DB2C? Have you played with it?
I'm AWS. Yeah.
Yeah. Do you know Cognito? Yeah.
Oh yeah, Cognito. Yeah, sure.
Yeah, it's the same. It's a managed authentication service, right? That we integrate with our application. And yeah, it's pretty much it. The reason why we decide to use it, it's because it's extremely fast, right? So refresh tokens, refresh in a stateless environment in like 40 milliseconds. So that was the first reason. And the second reason is that it supports a lot of interesting features like Web3 wallets, and you can implement SSO really easily, you know. So that was mostly the reason why. Also, we didn't want to implement our own authentication system because we understand that's a security risk, you know. I don't know much about authentication system. We don't have the know-how in the team. So we think it was the wisest thing to do is to use some service that's being implemented by experts that already handles most of that, you know. And then we just have to follow the good practices, and it should be okay, hopefully.
Okay. So just to, so you replaced the Azure
ADB2C
built-in Cognito or identity provider with the clerk that.
Yeah, exactly.
Okay.
Exactly.
Okay.
It was an hassle because changing authentication systems, it's really hard, but we powered through.
Yeah, especially because it's already a cloud-provided service, so it will be a lot easier to integrate with another services just using the Yeah, exactly. Okay, thank you very much.
Thank you for your question.
More questions for Marcel? Well, let me just hear it, and then I will.
First of all, congrats on your presentation and on your business or project. It looks really cool. My question is, when you were deciding on architecture, the decisions for the tools you have made, you make it really cloud, not cloud agnostic. You're using a lot of tools, and I know they provide simplicity, but have you, I don't know how to put it, thought about using like open source tools or some kind of tools more agnostic? For instance, imagine you're scaling up in Brazil and you have a lot of requests and your bill in Azure gets to the roof. And for instance, AWS or GCP could lower your costs. Have you thought on that case? For instance, you're using Azure message queue, you could adopt Kafka or something like that. I'm just asking if you have considered those kind of options to scale up your business.
Yeah, absolutely. Actually, I'm going to answer that probably differently than what we expected, but we are accelerated by Microsoft for startups, and they gave us over 200,000 euros in credits to use in Azure. So that's the 99% of the reason why our architecture is solely planted using Azure, okay? Because it's for free on my side of things. But now answering to your question exactly, yes, we are considering making that multi-cloud, have a multi-cloud paradigm in Network Me, especially when we move from app service plans to actually using Kubernetes or something like that. It will make a lot of sense because it's way cheaper in different places. Azure can be the most expensive for raw resources, right? GCP is usually cheaper. But since we still have credits to use, we are not making that evolution just yet. But it's on our mind, and we plan to do it probably in the next year or so.
Okay.
Yeah.
Thanks.
Thank you. Manel?
Thanks for the presentation. It was really great to see the evolving of the architecture. And you mentioned that you are going to have to scale once you go into the Brazil market. From the current state of what you have, what are you thinking moving forward to handle all this traffic that you are going to have? What are the main changes, or do you think, or have you already tested and get the metrics enough to make sure that you can handle all the traffic once you go forward? That's my question.
Yeah, great question. Thank you for your question. So in terms of scalability testing, we really haven't done like a very strong load testing just yet. This is very recent. We just launched it like previous week. So all of these new updates, together with the micro front-end architecture, which was also a very important change in our architecture. But the thing is that for reading operations, which is our major concern, we are using Azure Cosmos DB, and Azure Cosmos DB it's 2 clicks to scale it, right? So for us, it will be a lot more about monitoring, understanding how that impacts costs, and then evolve accordingly, you know. But yeah.
So it will be more on like containing the costs of what can happen, so it can scale out.
Yeah, absolutely. We have some strategies on how to handle scale. On the read side, it will be easier because since most of the readings are going through Cosmos DB, it will be relatively simple, right? So we just scale it down and then see if we don't bankrupt, right? But on the write operations, we have a few strategies. So one of them is to scale horizontally by having different microservices into different app service plans, and then scale them vertically from them as needed. SQL Database is the same. You can just scale it. It's a managed instance, so you can just scale it either manually or automatically. Currently, we don't have any automated scaling on none of the services because I don't want to break the bank. I'm worried about that. But we could, for example, set up some automatic scaling on a number of services, SQL, App Service Plans, Azure Cosmos DB. It's relatively easy, right? And the way we built the architecture, it allows us to do that. Not ad infinitum, but up to a point where at least we probably need to think about a new evolution, go into AQS, so we can scale up without any service limits, right? Because Azure Cosmos DB has limits. You can scale it up to X, right? But you can always add more machines, right? With AKS or something like that.
Yeah, really great solution that you have there.
Yeah, thank you.
Thank you. Sorry, any more questions?
Just one.
Yeah, sure.
Yeah, just to make sure that I understand everything. So you have 2 databases, one to read and another one to do the writing.
Yeah, exactly.
The syncing process, is that provided out of the box
No.
from Microsoft?
Yeah.
Microsoft, or do you need it to code that?
Yeah, you can have automated syncing process. In the past, I actually went through a path of using Azure Cognitive Search instead of Cosmos DB, but then we understood it was not really the way. And there was an automatic syncing, but it was very straightforward. So you sync like a table or 2, or you can make some joins and it will sync for a document. But sometimes on that pre-processing, you also want to apply some business rules, you want to apply some mappings, some operations, and in that case, it's easier to do in code. So all the syncing process for us is all done in code. It's an API that does 3 things. Reads relevant information from the database, right? Maps it into the document and applies all the different business rules and mappings that we need to form the document that we want to display on the UI and consume on the UI. And then it writes to those downstream databases, which is not just Cosmos DB. It's the 3 of them: Elasticsearch, Cosmos DB, and ReckonB. And yeah, so we do it all in code.
Okay, so that's why you fire the message to processing the event streamer.
Yeah, exactly.
And store on the
so the idea is that I update some table in our MySQL database, and now the data is out of sync with the Azure Cosmos DB, right? So I have to send a message to my data streamer telling, look, you need to upsert a new document with an updated version because it's out of sync. And it does all of that processing, updates the document, and moves on. There is actually a problem here, which I didn't say, is that this is not a completely synchronous process, right? So you mentioned I make a query, I receive a response, right? And everything is synchronous. I just have to wait on the UI for the response to be served, or for the request to be served with the response. But on this process, there is some delay, right? There is a delay of sometimes a few seconds, depending on how large is the message queue, right? And then we need to handle that on the UI, and often we also do it on the response of the write operation, we send some updates that you need to do directly on the UI, some of the properties, and yeah.
Send like SSE events through like sockets or something like that?
No, we just use
to update the UI or not?
No, we just wait for the response, basically. And because usually we just update on the write operation, we just update some small part of the document. We just receive the updated part, and it's a client-side it is a reactive client-side application, right? So we can just do things directly with JavaScript. You can just update it directly there, and it will reflect on the UI instantly if you want. Or if you need some information back from the backend, right? You can just wait for the request, and then basically with that information you update UI. That's the way we handle it.
Okay. Awesome.
Yeah.
Thank you.
Thank you.
So you mentioned that you started as you are a startup, and you started with just one. It was just yourself.
Yeah, it was just myself.
Company.
Yeah.
What tips or how did you motivate yourself to grow your company to what is already where it is?
Well, that's a hard question to answer. I think everyone has different motivations, right? So for me was I have to work, otherwise my company is going to die. I cannot rely on anybody else. So that was, I would say, the major motivation. And then obviously I was inspired to do this, right? So I wake up excited to work on this, right? And for me it was a learning journey, because although I'm bald and I have a big beard, I'm actually quite young. I'm only 27. So when I started Network Me, it was only my second year of professional career. And I was just excited that I could learn so many things, you know? And sometimes when you work for a company, you don't have that many opportunities to learn what you want to learn, right? And I can give you like a number of examples where I did mistakes. Mistakes that hinder the business, right? But actually it was important for me because I was learning, right? And that's awesome for me, you know? And that's really motivates me, having the ability to learn like a diverse range of things, right? And yeah, and now I'm how do you say, a jack of all trades but a master of none, right? But that's my profile, you know, so I like it.
Thanks.
Yeah.
Thank you, Marcel. Any more questions for Marcel? Another one. It's the last one because the pizza is getting cold, so yeah. Just joking, yeah.
Thank you. So, yeah, part two. Yeah, you said you use free read databases. One is for Recomb or
Recomb, yeah.
Yeah. So another that is MongoDB.
Elasticsearch.
Oh, Elasticsearch.
Yeah.
And the other is Azure.
Cosmos DB. Yeah.
Oh, okay. Because you said earlier you mentioned Mongo, and I was.
Yeah, I probably said it wrongly because it's the same.
Okay.
MongoDB and Cosmos DB, they are practically the same.
Yeah, my question was towards that. If like, if you were using Mongo, or is it quite the same? If you think that maybe not now, but in the future you'll replace with a faster read database such as Redis or another one, if you could get the extra performance on.
Yeah, excellent question. So the beauty of this architecture is that I can just plug in, plug out components, right? So if tomorrow I want to replace Azure Comms DB by MongoDB, it's extremely simple. I just change the connection, the client, you know, problem solved. And then obviously I have to reintegrate things on the UI and so on, but on the development standpoint, it's quite simple. And if I want to support other paradigms, like having Redis for read performance, or if, for instance, I want to explore like a graph database to, I don't know, have a use case that I want to support in the product where I want to recommend things based on connections, right? It's very simple. I just need to, again, plug in a new database there, right? The syncing mechanisms will continue the same. I don't have to do anything else on the other APIs because they're already triggering when they have to trigger. And then I just sync, you know, it's quite simple. So that's why I really enjoy this, is because we can introduce new things without increasing the complexity of the software, you know. You just plug in things there and it will work, you know. Did I answer your question?
Yeah. Okay, so So in the like event-driven, you said you can easily plug in a service. So basically, you'll just need to put like a Redis or Mongo, whatever, and then insert in the event-driven architecture that call. So you'll need to change microservices software. It will just be the connection, the bridge.
Actually, the only update I have to do is in my data streamer, and practically I have to have a new client. Perhaps there will be some extra business rules I have to support there, but that's it. You know, the right APIs, they are going to stream events using messaging bus on the same times they have to, right? So I update the document, there was some update there. I have to tell the data streamer that he needs to reconstruct documents on other places, right? And yeah, I can just have Redis cache, I can add a graph database, I can continue adding things on the top side of things, and I won't have to change much in terms of the software package, you know?
Okay, thank you very much.
Yeah, thank you.